That's a bad start to the video. Okay, sorry, internet people. We did break down, and we'll do this during the video, broke down some stuff about what we need to know about a parabola. So just stop and write that if you want. Showed where parabolas are in the real world. Reiterated what vertex form was, and now we started a new form. So go ahead and write that down. Sorry for not starting the video earlier. This is intercept form. And I am going to tape some students. Who are we on right now? Yes, we already had Jad. We can use your first. Hey, look at that, Jad. You should play the lottery today. You got picked twice in a row. Nice. Are you ready? Hey, Jad, are you ready? Nice. It's all right, Jad. You'll be fine. Hey, Jad, what form is this for our first example? Is it intercept or is it vertex form? This is what you have to do as a student now. You have to figure out what form am I dealing with, and therefore I'll be able to get, help myself out getting this graph. Which one is it? You are correct. Okay, and don't worry, you're the first one. Don't worry if you get this wrong. What are the x-intercepts? Remember, x-intercepts got to be in coordinate form too. Yeah, I'm throwing it out there. Put you on the spot here. See if you can figure it out. The same thing happened last hour. Let's analyze if we put -1 in there. -1 minus 1 is -2. Oh no. I really wanted this to be, starts with a Z. Really wanted this parenthesis, starts with a Z. Z-E. Z-E-R. 0. So not -1. What actually is the x-intercept? It's what? What, when I plug this in, this turns into 0 here. And then I'll explain it. Not -1, but just take the negative off. No. Take the negative off of 1 and you get, it starts with a 1, 0. And I'm going to explain it right now, Jad, why this is the x-intercept, or one of them. So I have f of x, which is the same as y. And then what we inputted was 1 for x. And I am going to over-explain this. And yes, Jad, it was unfair that you had to go first. It's fine. Hopefully now it's like solidified in your head, because 1 minus 1 is 0, and then 1 minus 5 is -4. Hey, Jad, what's 2 times 0 times -4? So when I plugged in 1, I got 0, which proves that this is an x-intercept. Input, say it again, Jad. You're getting sick of saying it, though. Input, yeah, this is what graphing is. What if it says 8 again? Oh, okay, 4. Who do we got now? Ryan, you ready? So what's the other x-intercept then? You are correct, sir. And what would happen with this is I'm just going to go ahead and erase and be a little bit lazy. I'm going to erase that 1 now and plug in 5. And now we get 2 times 4 times 0, which of course is 0 as an output value. So that's what I'm going to put on the chart. And I'm actually going to graph those 2, 3, 4, 5. Graphing 101, inputs, outputs. All right. I'm going to ask you one more question, Ryan. Where is the axis of symmetry? Like, what x value does it go through? Let's see if you were focusing on that last page that we were talking about, or I can help you. I forgot to write that down there, so I got to put this down at the bottom. A axis of symmetry. Where is it located? Just give me the x value. Oh, you actually went further. Nice. 1, 2, 3, 4, 5, 3. So here's where the axis of symmetry is. Correct. Nicely done. You're off the hook now, unless you get called again. So sorry that got cut off. Somehow I cut off that bottom part, axis of symmetry, which means the vertex x value is 3. All right. And that's also fumble. I almost fumbled my pen. Okay. I don't know if you saw that in the screen there. All right. Good. I think you've done awesome there. So I'm going to go to 2. Nice. Matt. You ready, Matt? Okay. So how do I get the y coordinate for the vertex? What do I got to do? I'm going to erase my work up here. No, that's for something else. I want to find the vertex. So input, say it. So I input 3 in for what letter? What letter does 3x? And I solve for, there you go. Actually, what you said there, you may have been looking at the next blank. Is that what you did by chance? Okay, all right. Sorry, I just choked. 3 minus 1 is 2. And then 3 minus 5 is -2. Okay, Matt, you're off the hook if you get this. What is 2 times 2 times -2? Just to do some math and exercise your math brain. You are correct. And then we'll go ahead and graph that. And it should make sense, everybody, that this is going up now because it's a leading coefficient of 2. Okay, good. Nicely done. Hey, remember what Matt said there, maybe. I don't know if he was on to something there, but Emily Ann, how do I find the y-intercept? What do I input for who? Yeah, correct. And I'm going to put it right here. So y, f of x is the same thing as y. I like going back to writing it as y so we understand input 0 for x. What do you get for an output value, Emily Ann? You are correct. And I don't know, I shove this on the 1, 2, yeah, 0 would go here. And then there's something else you could do for this, Emily Ann. What other x coordinate gives me a value of 10 for y because of symmetry and the axis of symmetry? See if you can, that's a high level question there without plugging it in. You know? Here, I'll give you a hint. I don't want to give it all the way. Symmetry. So if you flash to the other side of the axis of symmetry, blank comma 10 would also be a coordinate. Yeah. Because of symmetry, when I plug in 6, I should also get 10. And you could check that. 6 minus 1 is 5. 6 minus 5 is 1. 1 times 5 times 2. Absolutely. And sometimes when you're doing these input outputs, you don't necessarily have to write them. That's why I keep writing them and then erasing them, because I'm just kind of doing it for my work off to the side. And this is what you were supposed to do on yesterday's 3-2 thing when you had to find another coordinate after the vertex. You were supposed to input output on a sheet of paper, get another coordinate, then go back to the graph and toggle that point. And then the parabola would be created. I covered that yesterday in our meeting. So yes, we need to get that stuff done. Okay, I did cover this. So let's see if we can get this students. Yay! Ethan, you're student number 1. Don't let anyone tell you any different. Hey, what's the domain, Ethan? And then what's the range? A tougher, more restricted question. Oh, I didn't graph my graph. There we go. Not too bad. Okay, remember what y values are covered? These. Say that one more time. What do I put on -8? Correct, because it is included. And someone asked me that question before. Oh, thank you, by the way. Someone came in and gave me something. Hopefully I didn't screw something. No, cancel. Oh, okay, never mind. Oh, I never did do attendance. Save. Stay. Oh, sorry. This is great. Leave. Apologize, the video here. Just got to do my due diligence and do attendance. All right, good, Ethan. You're off the hook. Nicely done. All right. Just some technical difficulties here. I'm actually screwing things up here. Now I'm good. All right, and then minimum and maximum. There is actually a minimum for this. It is the y coordinate, which is -8, and it occurs when x equals the x coordinate of the vertex 3. And then I cut off intervals of increase and decrease, or I cut off decrease. Increase, I'll go ahead and do that one just to speed things up here. This is increasing right here. I got to erase this. But we name it, just like I think it was Patrick today that we were covering intervals of increase and decrease. We name it with the X's that are plugged in. So it's increasing 3 to infinity when I plug in those X values, decreasing negative infinity to 3. And always use parentheses on interval of increase and decrease. Any questions? Oh, I didn't put Vertex here, but I put it in the chart. So, all right. Okay. Let's get the next student. Yes, 11. Evan, your number's up. Hey, Evan, what form is this? As I fill in some parts I'm missing here. Oh, I see a lot of. Yeah, it is vertex form. Okay, so hey, does caret mean I have the same thing? Infinity is always parentheses. Yes, parabola includes that number. I missed that people were putting stuff on chat. So Alexander, infinity always parentheses. Why wouldn't there be a bracket on 1? Ethan, do you still have that question? Okay, my bad. Oh, I guess I do see that. Did I answer it though, or is it all good or no? Okay, sorry. Sorry, I wasn't paying attention to the chat. I'm too many things going on. I can't. Hard to do that. Okay, so back to Evan. So what is a vertex? Oh, remember the vertex is, it also, another way to think of it is, hey, it's like the zero, like what makes a 0? So it's 3, 1. Yeah. So think opposite, same. One way or the other, that's what we have to think. 1, 2, 3, comma 1. And that's why I did this. I wanted your brain to already like analyze what form do I have? Therefore, I have to do something different, like with each form, to make my life easier. Hey, and I have one more question, Evan. Which way is this going? Actually, 2 more. Which way is this facing, up or down? Yeah, why? So I see you like kind of looking at the notes there. Why do you think it's going up? Yeah, or well, not K. It's actually A. This is positive here. So now I have one more question. If this is going up, what are the X-intercepts, or do you have any? Well, don't look at your notes. Look at this picture. Look at my screen. Wouldn't that have to go up like that? What would the X-intercepts be, or would there be any? X-axis is down here, and this parabola is going up when we actually graph it. Will there be X-intercepts? No, and that will happen. So not only is this not intercept form, this particular parabola does not have any X-intercepts, and that is going to be something that will happen. So I just wanted to make sure you understood that as we move forward. Nice. Is that a double ask? Jad, your number came up again. Is this your second or third time? Okay, we'll go real fast. How do you find a y-intercept? Look at the previous example. What do we plug in? What'd you put in for x? Oh no! Look at the last example. We put what in for a y-intercept? 0, and then we did get 10 on that last one. I didn't finish that off, but I put it in the chart. So we're going to put in 0 for x and solve for y. So we're going to walk you through that. Hey, this is going to be, oh no, this is going to stink. What's 0 minus 3? Squared. What's negative 3 squared? What's 9 times a half? I'm going to do this for you. It's 9 halves. You should get used to fractions. 9 times 1 half, 9 goes up in the numerator. 9 times 1, actually 9 is the same thing as 9 over 1. This is important for me to cover, by the way. So many students do not know how to deal with a fraction. It actually makes me infinitely sad. So 9 times a half is actually 9 halves. Then to add that to 1, you do what Lexi Samuelis does, my 10-year-old. You change 1 to 2 over 2, getting a common denominator. So 9 plus 2 is 11. So the y-intercept is 0, 11 halves. Okay, fine. 11 halves is 1, 2, 3, 4, 5.5. All right. I have an axis of symmetry through the vertex. And even though this is not a clean point, like it's a fractional point, 26, nice. Patrick, that's number 2, I think, right? Patrick, what's another point for x that would have 11 halves for a y value? I don't want to give it all the way here. So zooming in on that y value is 11 halves, and this is an axis of symmetry. So what would be the other x coordinate? Flashed over. There we go. 6. Okay. And then you can prove it by plugging it in, input, output. I don't really have hard, fast rules how many coordinates you have to plug in. Minimum would be 3, to get this picture drawn. And you can use symmetry to find that other coordinate. It's very easy to see that this is true. 6 minus 3 is 3. 3 squared is 9. You have 9 times a half plus 1 again. That's why you end up getting the same y coordinate. Okay, so Patrick, you did a couple things there. Hey, nice. We're getting a lot of re-asks. That means when you go, you might have to go again. Ethan, what's the domain? That's funny. You got the same questions again, too. Range. What's the range? Nice. Correct. You're done. Oh, you didn't say bracket, but I'm sure you knew that. Okay, and then what's that? Oh, okay. All right, gotcha. All right, and then the minimum is, sorry, yes, it is a minimum. It is a minimum again, and that's at 1 when x equals 3. I'll do the intervals of increase and decrease. Increase from 3 to infinity, right? Yes, just wanted to make sure. 3 to infinity, and then negative infinity to 3 for decrease. So the other teachers were using all this terminology here, so I wanted to make sure I threw that out to you as well. Okay. All right, got to move along. 22, that's new. Ethan, right? 22. Hey there, Ethan. Hello, what form do you see here? And it's actually, we really should call it X-intercept form. I know we didn't call it that because you have more than just an X-intercept, but it's really X-intercept form. And then what are those X-intercepts? Remember what we did on the intercept question. So this should produce an X-intercept. What would that give me as an X-intercept? Oh, you did the same mistake. -7 does not make this 0 on the inside the parentheses. Not -7, but what makes this 0? What number minus 7 equals 0? So what number could I replace for x? What minus 7 equals 0? Not -7, but just get rid of the negative, Ethan. 7, 0. Again, y equals -3. When I plug in 7 for x, I know this becomes 13, but this becomes 0. 0 times -3 times 13 is 0 for an output value. So what's the other one, Ethan, now that you see that? What's the other X-intercept? Yes, because when I plug in -6 for x, this becomes 0 times -13 times -3. which is 0 as an output. Input, say it, Ethan. Input, say it, Ethan. Nice. This is graphing 101. This is why this all works. This is why this method should be, really understood. Not method, this form. 17, mixing it up. Jack, nice. Hey, Jack, where should, this is going to be crazy, where should the vertex be compared to these two x-intercepts? Where should it be? Or where should the axis of symmetry be, which is the same thing? Just in general. In between, and I think you're stumbling because we're going to have a fraction. Do you get that? Yeah. So this is how we find it. It's just, this is where it becomes kind of a formula where you take that 7 plus -6 and divide it by 2. That's the midpoint of those x coordinates. And what do you end up with when you do that? You get what? X equals a half. And I'm going to write that. I'm actually going to draw it. There's a half. We're going to keep our scale. And then, Jack, one more thing. What do we know about the vertex then? So what is the x coordinate of the vertex? Do you see my, look at the screen. There you go. I was giving you a hint. So 1/2 comma something. All right. Okay. I'm going to ask another student. Student number 6. David, you ready? Input. Say it. So when I input a half, I should have gave myself room for the vertex. Oh no, David, we're going to have to go to a calculator. -3 times, a half minus 7, oy, and a half plus 6. Oh, you tell me what you get on the calculator. This is a time when the calculator probably would come into play because that's annoying. I know I just yelled at you should know your fractions, but yeah, go ahead. What do you get? Okay, I already have it. I just want to check that you can calculate it. And we'll wait. We got the time. It's only 10 minutes. I told you we were going to full time. Ooh, and I'm going to hit about 4 more students here. Not hits. I didn't say I was going to hit anyone. I can't through e-learning anyway, so that's impossible. All right. So, no, that was a lie. It's a big number. Oh, no. I got well, nice. You are actually correct. So now what we have to do is this. We got to change our scale. And you might want to mark a couple X values, and you don't have to pick mine. You might go by 25s. I don't really care. I went by 20s. As long as you mark it, at least a couple, or at least one scale value. 20, 40, 60, 80, 1, 20, 40. So you're somewhere right around here. Right? Okay, yeah, so this can happen. So we just have to adjust our scale and we'll be fine. Hey, this is Patrick. How many, is this 4 times, Patrick? Okay, you can go then. What's the y-intercept? Or how do you find it? What do you plug in for who? For who? Yes? Yes. So go ahead and do that real quick. You guys are all supposed to have your calculators right by you. Hey, yeah. Yeah, what's up? 19. Oh, no. Oh, jeez. Gotcha. Cool. The probability of getting picked 3 times, and I think 2 people have been picked 3 times. Hey, Patrick, you got that y coordinate? No, you do. It's -3 times -7 times 6. So you just keep and then multiply that by 6. You should get 126, right? Okay, and then because of time, so I don't know where to put this. I guess it's kind of in here. This is terrible that I have this out of order. But 0, 126. What other value has a y value of 126? Half, half, 1. 1, 126, right? Right, because I flipped over the axis of symmetry. All right, and I think we've answered these questions enough, so I'm going to fly through the domain and range. Domain, of course, is all real numbers. Range is this high value, but remember you have to do this in order from negative infinity up to that high value of 126.75, which is a maximum now of 126.75 when x equals a half. Intervals and increase and decrease, I'm going to skip because I got to get to these last examples. Okay? All right. Just because of time, we keep redoing the same stuff here. Okay, and then we'll probably only get a couple of these, and then I'll talk about what the other two are like. Hey, student number 8. I think that's another. Holy cannolis. Jad, is that 4 times? 5 times? Jad, I'll leave you alone. Boy, the probabilities of this is just getting out of control. Genevieve, nice. Here we go. Hey, Genevieve, when you see this question, what do you think you should use? Should you use Vertex form or should you use the new fancy Intercept form based off of this given information when you read example 4? Which form? Intercept form, which is this one. Yep. Now, if you remember what we did when we had Vertex form of this kind of question, you say to yourself, okay, it gives me the X-intercept, so I should use this form. Now I'm going to give you, okay, you have the tough question here. Where should I put 4? Like, what should I replace that with? Y, A, X, P, or Q? You have actually 2 possible answers. Where do you think 4 should go? Nice. Awesome. We're going to be rocking and rolling here. Where do I have to put -2 now then? Nice. And then I have this other arbitrary coordinates, which happens to be a y-intercept, but it's not, you don't use the y-intercept in intercept form. It's actually x-intercept form. So where do I have to put 0? Nope. Nope. Try again. What is 0? What coordinate is that? Just in general. What coordinate does 0 represent? 0, 4. 0 is the what coordinate? So where do you put 0? Spots. Then where do you put 4? Negative, sorry. Where do you think you put -4? Nope. -4 is the what coordinate? Yeah, and then just like in intercept form, you plug in these numbers in these spots to find A. A is the one that says, if I were to graph this, what is the dilation? Actually, the term is dilation for those stretching or shrinking values of A. So that's what we do. We understand we have intercept form, and then we plug in the numbers in the appropriate spots, meaning the intercepts are P and Q, so those go into P and Q spots. The other coordinate given just goes in for the X's and the Y's. Then we solve. -4. This is -4 times 2, which is -8. I'm going to trick you here, Genevieve. What is A equal to? Be careful. Last hour made a mistake. What's A equal to? Dang it! You made the same mistake as the student the other hour. Whatever I do to one side, I do to the other. What is -4 over -8? Yeah, that's a common mistake. People stopping short and not doing whatever they do to one side, do to the other. All right, so this is the equation. Just like in intercept form, or I'm sorry, just like in vertex form, you bring the y back, you insert the new 1/2 that you found, you bring the x back, but the intercepts will always be the intercepts for this particular equation. So you bring those back, and just keep in mind, look at this. 4 is the x-intercept. X minus 4 ends up being what's called the factor that goes there. Okay, and then maybe the last one, and then I'll verbalize that last one with the student as the bell gets close. Oh, who got caught at the end? Sydney? You almost got out of here unscathed. Hey, what form do you think you should use for this one, Sydney? And then you put that in, meaning, okay, I have a vertex, so I'm going to use this form now. Okay, and then where does -4 go? What letter, Sydney? Where does 2 go? Where does -6, the first one, go? And then where does the last one go? That's how we do this. Hopefully the highlighting is very helpful on this. -6 minus, let me just make sure I'm -4, and then plus k, which is 2. And then because of time, I'll go ahead and solve. Make sure you do this correctly. This is +4. So this becomes -6 plus 4, which is -2 squared. That becomes 4a. Subtract, and then a equals -2. Okay, and then final answer is plugging it back into vertex form. X plus 4 minus -4 squared plus 2. So we're toggling back and forth between the two known forms of parabolas. I will continue the video, but just understand that this question is exactly like the last one, but it's just a picture instead of listed information. That's a vertex given, so I will show you that you use vertex form. This one, this is X-intercepts given, but it's just in picture form. So it's just like the first example, okay? But I'm going to keep making my video and finish this off. You may walk away. You may go. Remember, today it's 1 o'clock to 2 for meeting. I'll have it on at 2, but I'm going to be in a book meeting. So just for video purposes, as my third hour leaves, this is a vertex. So I'm going to choose vertex form. I'm going to write down that vertex form. So you got to be able to toggle between these two forms of a quadratic. This is the x coordinate of the vertex. This is the y coordinate of the vertex. This is another arbitrary x comma y. I know it's a vertex. I'm sorry, that's not right. I know it's a y-intercept, but y-intercept does not deal with intercept form. Really, we treat this as just another arbitrary x comma y. That is not, in this case, the vertex. Okay, and then for solving purposes, -1 squared is 1. No, you don't add 1a to 2. You subtract 2 and get 1a, or a equals 3. A should be a positive. You bring y back. You insert that a. You bring x back. And then you insert the vertex, because this will always be the vertex for this particular specific parabola. These x's and y's come back because now we can create all these other coordinates and find out what they are by input-output if we wanted. All right, and then the last one, I just did this for purposes of what our CAT book does. This is the scale. Sometimes they write this at the bottom of a coordinate plane. Doesn't always have to be go by ones. So if it said like 100 to -100, I should reverse that. Then the x-axis goes from 100 to -100. If this said, so sometimes they do that, and I just did want to cover that, but we don't. It's not what we have. So I'll back. And then looking at this those are x-intercepts given. So we are going to use intercept form again. 1, 2, 3, 4. 1, 2, 3. I feel like I counted bad there. 1, 2, 3. So sometimes you have to count to figure it out. And then yet again, I gave the y-intercept as an arbitrary another coordinate. So since I have the x-intercepts, I'm going to use intercept form. I don't know why they use P and Q. Doesn't really matter as those letters. Then same old, same old. Arbitrary y-coordinate is the 6. Don't know A. Arbitrary x-coordinate is the 0, comma. And then the P and Qs in any order that you want, minus -3, -4. This becomes 3 times 4, which is 12A. -12. I knew something was wrong because this is going up. That's -4 times +3. Then divide by -12, and you get A equals 1/2 again. Final answer is y equals 1/2 x minus the x-intercepts. And that will be that parabola there. Okay, I will stop the video. Ooh.